The term imaginary number always feels off-putting. Like, what are we doing if we're finding imaginary solutions? And I wanted to talk in this video really about what the definition is, and also why in math it's a really nice situation to have, because it adds some clarity and some kind of concreteness to looking for roots. There are also real-life applications to imaginary numbers that I'm not going to get into in this video. I kind of just want to define them and what they are. So the definition of the imaginary number, denoted as I, is it is the square root of -1. That is the definition of our imaginary number. Okay? The square root of -1 is I. So to kind of work off of that, if I said, well, what's the square root of -4? You could say, well, the square root of +4 is 2, but because this is negative, it's 2i. And, of course, square root of -9 would be 3i. That. If it was something that wasn't quite as clean, let's say it was the square root of -12, which we can rewrite as, 12 is 4 and 3. I'm going to put the I here because it's going to be imaginary. So 2 square roots of 3i, or 2i square roots of 3. The order could be different. But this is a denotion that we were taking the square root of a negative number. Now, another thing to know about imaginary numbers then, if we could kind of work the opposite way, if I said to you, well, what is I squared? Well, looking back up here, if I squared I and I square this, the square root being squared gets rid of the root, so it's just -1. Then I to the 4th is the same as I squared times I squared. Well, that's the same as -1 times -1. That's 1. If I said, yeah, but what's I cubed? I cubed is the same as I squared times I. I squared is -1, like that. So we can also kind of almost use this alternate definition of I to do some simplifying as well. Now, why I said this adds some clarity to math problems is because we have root theorems. We have theorems that deal with how many times a function hits the axis. And oftentimes, if we have let's just make up a cubic function. A cubic function, an x cubed, can hit the axis 3 times. X cubed 3 times. So we can use that power. We say, okay, so the highest degree tells me how many times it hits. But then we could have a cubic that looks like this. And that cubic only hits once. So then we had to modify our theorem, and we had to say, okay, it was x cubed. It hits a maximum of 3 times. But here's what the imaginary numbers do. The imaginary numbers will give us 3 solutions, but some of them could be imaginary. But we know if it's x cubed, there are 3 answers. Might be a mix of real and imaginary answers. Real means we actually can see it hit. Imaginary has to do more with a distance away from the axis up here. But we know if we include the imaginary numbers, we'll always have the same number of solutions as the degree. And that adds some nice clarity. If I say, hey, it's x to the 7th, you say, I know there's 7 answers. Now, they might not all be real. I might not see them all hit the axis, but I know there are 7 answers. And that's a nice thing. That's a nice certainty to have in math. So again, imaginary numbers, the definition really is that it is the square root of -1. And keep in mind, this is just a nice notational thing, so we can put other numbers in here. We would just have the I at the end. And this alternate definition, which I can use to kind of have higher powers of I. Okay. If this video helped you, please like and subscribe for more math help.